Martin Hobson. I work for Agilex Technologies. Some of you may know we were just acquired by Accenture, so shortly I'll be with Accenture. My partner in crime in this is a gentleman by the name of Anthony Antonat. Brady couldn't make it today, but what I'm going to show you today was actually a learning exercise for him as he was coming on board one of our teams to get comfortable with Jenkins and DevOps tools. DevOps is what people say it is, kind of. What most people take it to mean is the use of scripts and automated tools to create virtual machines and infrastructure. But there's more to it than that, and something that people conveniently forget is that DevOps actually includes measurement and iteration as part of its founding principles. So if we're looking at a Jenkins job that does a lot of DevOps related tasks like create VMs and interconnect them, one of the things that we should know if we're serious about iterating and improving is how long it takes to do these things. Are they happening in the order that we want them to happen in? And where can we make things better? Where can we improve? You heard our previous presenter talk about how important it was to cut down people time and run time in the jobs, and that certainly applies in our world too. Even putting things into AWS as we do, it still costs time and takes time to run these things, and people are waiting for the results. And we can't assume that everything happens instantaneously just because we've moved it to the cloud. We still do have to pay attention to the finer points. And it can be hard. Let me tell you a little bit about the project that we were working on, why this was so important to us. Come on. Last year I was assigned as a troubleshooting team onto a project that was building a large portal system for the Veterans Administration. The goal was to build a system that would sit at bedside and allow clinicians, doctors, nurses to get a single view of all the information the VA had on a patient. That could be sizable, and they get their information from all over the DoD enterprise. It's a big place, there's lots of sources of records, and it can take quite a while to get them all. So in order to improve patient care, they wanted to have a system that could be told the patient was coming, then go out and collect those records and present them in a single view, so they had a complete view of what was going on with this person they were dealing with. It's a classic stovepipe system. We were trying to bring all those stovepipes together, and that work is still in progress. To support this, we used a fairly standard Jenkins environment. It's all in AWS. It's sizable. At last count, when I left there, they were running somewhere between 200 and 300 instances in that CI cloud full time just to support the build pipeline for this project. We used a fairly standard strategy where you first did a unit test build. If that was successful, you promote it to an integration test build, and then you move on to the acceptance test build, where we actually stood up as complete a system as we could in that environment with data sources, honest to goodness incarnations of the VA database systems with seed data and some other third-party systems. They'd all come together there, and we'd experiment to see if we'd test to see if our portal system actually could, in real life, bring all this data together successfully. It was, as I mentioned, per build, the number of VMs that these builds would stand up just to make this happen was somewhere between 8 and 15 VMs per build, given multiple branches in operation and different versions, or different commit levels, different commits being run at the same time. That's where that number of 200 to 300 instances active at any one time comes from. It'd be maybe 10 or 15 builds running in parallel or sequentially that required that level of support in AWS. It was not cheap to operate that cloud, and it's still in progress. The other thing that we saw was that we had some fairly complex startup flows. This is a complete production environment, so if you imagine what you would have to do to make that work, a sample of what we were dealing with is shown here. As part of our provisioning flow, the first thing we would have to do is stand up the basic LDAP server for the whole environment, basically, where we kept user credentials and passwords and where everything that happened after that was validated against. Then we'd stand up a relational database system that had core records that would be fed into some of these stovepipe systems that would format them and produce individual patient records. And there were some other pipeline systems that would collect data from elsewhere that had to be brought up. And then, after all these preconditions were met, then we could initialize the VMs that contained our actual code that would go out and touch these systems and consume data from them and format them and present APIs to our web interfaces. And that was a sequence of 2 or 3 steps after that. So this is a notional diagram. This is not actually what was happening. There's quite a few more systems involved in our actual flow, but it's not a trivial thing. You can see at least 1, 2, 3, 4, 5 levels of things that had to happen in sequence for this to be successful. As it happened, at the time I was working this project, an individual acceptance test build took about an hour and a half to run. There were 100 developers on this project committing frequently, and well, even AWS, even our allocation of AWS had a hard time keeping up with this. We found our build pipeline slipping further and further behind the actual change frequencies to the point that if you put in a commit, you would have to wait a day or two for the acceptance test build associated with that commit to complete. And that is just not acceptable. That was just not working because what would happen is somebody would break it the previous day, they wouldn't find out till the next day, and then you'd have a cascade of commits piled on top of that you have to roll back to see what had happened. And with 100 people depending on this, I mean, the management headaches are immense. You can't just tell everyone to stop work while we go and sort out what happened 2 days ago because of Joe over here, and undo everything you've done because Joe made a mistake and we didn't find out until days later. It's just not a good scene to be in. So it was important for us to see how we could possibly optimize these builds to make more of them happen more frequently and stay on top of our change frequency. With booting 15 Linux systems, the output, the console log output from them is immense. It's a lot of data. We installed then software on there as well, and that would all be pushed into the Jenkins console log, and it was all tagged, so you could, using grep or fgrep or whatever you want, separate the individual system logs, but I'm sure you could imagine that nobody ever did that because it was just a lot of work to figure out what was going on inside of these individual VMs. So as a first step, all of our provisioning was driven using Ruby scripts. That's your standard chef kind of it's one of the standard tools that's used in this space, and it's a procedural language, and we'd write these little Ruby programs to initialize the VMs, and we could easily say, wrap our provisioning steps with timing information and capture the actual time required to boot and start up and configure VMs at the various points that when they would start. And we emit this data as timestamps into our log as a first step, and then later on we'd simply go to the logs and collect the timestamps out of it, and then we'd have the times required by the individual provisioning steps, and we could look at this tabular report, and maybe if you're a computer and you can figure out what the number of seconds since 1970 means exactly, it makes sense to you, but it didn't make a lot of sense to me or my management. What we really wanted was something like the chart down here below, where you can see those are our first presidents. You can see that they don't overlap, that they have about a one-term president is about this long, and a two-term president is about this long, and everything kind of makes sense. It's not broken. It's working the way you expect. Just looking at that, you could tell. If you saw the actual dates, you may or may not be able to figure that out. But a graphical display here would have been helpful. So we had these build timestamps, and we scratched our head and we figured it'd probably be easy enough to get them into a chart like that. That what I showed you was just the standard Google Charts example taken from their first Hello World homepage for that tool. And we said, well, if we could somehow get these timestamps into that form, that would be fantastic. But how do we get them? The Groovy build log, the Jenkins build log isn't really a workspace artifact. And if we could somehow get that into the workspace and turn loose some build scripts on it, we could easily pull out our timestamps and inject them into a graph like that. But the workspace kind of exists in the parent Jenkins servers and doesn't make it down into the children very easily. So we were able to make that happen using some post-build Groovy scripting that talks to the Jenkins object model. A few trips to Stack Overflow sorted this out for us. It's not a common thing to capture your build log and place it into the workspace, but we did have a need for that. We discovered how to do it, and this is the code fragment that we use. You can see references to channels and file paths. That has to do with the fact that our builds actually are remote from the Jenkins servers where the jobs reside, and you do have to, you can't use the standard Groovy and Java file objects to manipulate the Jenkins files. You have to use their remoted files to make that happen. And what you're seeing there is some special logic to make sure that even though these things are separated, we still can capture the actual log and push it into the workspace. Once that was done, we wanted to inject it into this piece of HTML. This is, again, taken right off the Google example. This is actually that president's page with the name of the president replaced with our event ID and a start and end tag, and then a little magic comment put in that bottom part where you can see the data table. That's where the individual event rows would go, and we will then script an injection of our captured log input and stick it right in there. And well, let's see. Right, that's this next step. We capture the individual, we format timestamps that come out as JavaScript as it happens. We can do that, Ruby writing JavaScript, not a problem. We format them properly for injection into the chart. We label them so they're easy to find in the log file. Then we grep them out of the log file with a post-build script, and we use sed, a little bit of a post-build, some standard Linux tools to take those log file fragments and inject them into that HTML template. And once that's done, we wind up with this. So this shows the flow of about 12 VMs being provisioned in one of our acceptance test jobs. And nobody, until we did this, nobody had seen what really happened in these jobs. And one of the first things that struck us was that the actual acceptance tests were the smallest part of the work. They're about, the overall job is about 1 hour and 15 minutes. The acceptance tests take about 20 minutes. And prior to our doing this, everyone had assumed that the acceptance tests were the long pole in the tent. But now we knew conclusively that that was not so, that if we worked on our provisioning, that's where we had to pay attention, and that's where we had to start looking to make some headway on our build times. One thing we noticed was up top there, these up steps, those represent the initial configuration of AWS images. I'm not sure how familiar you are with that, but the first thing you do when you start a system in the Amazon cloud is you tell it, boot a known boot disk, and then once that's done, you can continue and provision it with your recipes and drivers. And that initial step, we knew we needed 12 nodes that all kind of looked the same, use the same base Linux image. So we launched them all in parallel using a Ruby build tool, and you'll notice that one of those steps is not executing in parallel. That bottom one is offset from the previous steps, and if everything had been working as we had expected, it should have been launched at the same time. Closer look showed that we hadn't configured the thread pool large enough for our build tool. There were some undocumented command line parameters apparently that we had missed. An inspection of the source code of the Ruby rake tool allowed us to find that out. And so we were able to shave 5 minutes off just by identifying that this one little step could be run in parallel. Looking a little bit further down, we noticed that some of our provisioning was suboptimal. We had some of these things that we could overlap more aggressively, and thus we were able to shave this down, and we were able to cut the provisioning time in about half by noticing that some of our dependencies were too conservative and that we could move some of the provisioning steps up forward. So we were able to almost double the rate of our acceptance test runs by inspecting this and moving and applying some optimizations. The next step was to use the Jenkins report publisher to capture the artifact and push it out so it was visible and archived as part of every build. If you can tell Jenkins that there is a directory in your workspace that contains HTML, you can tell the report publisher to capture that, all those artifacts, bring them into the Jenkins build records, and publish them through the core interface. And we were able, that was a trivial change that we then added to it and made it visible through our entire team. So in conclusion, this was a very low-tech thing, a few trips to Stack Overflow, a few trips to Google Charts homepage, a little bit of time in figuring out the Jenkins object model, 5 minutes of Groovy, and we were able to produce a fairly compelling visualization that we were really able to put to good use. And this was not necessarily limited to just VM provisioning. you could easily timestamp other parts of your build process and consume it using the same technique. And if you do have builds that are time sensitive and where you're trying to figure out what is going on, this could be a valuable addition to your toolbox. It's by no means restricted just to provisioning, although that's where, because of the complexity of those flows, that's where it was really valuable. We saw that some of our flows we could do better by actually visualizing and seeing what was really happening earlier. So we're also able to present that to our management. We could say, you know, well, we really need to look at this area of our architecture and see if we can simplify it because it's causing a lot of issues in our build pipeline. And they may not understand tabular reports, but when you can show them a very simple flow, like a Gantt chart like that, they certainly got that, and we were able to communicate effectively to our project management and make some change happen inside of our project. Well, that concludes my presentation, so I'm open to any questions if you have them. Bear in mind that I'm just a peon and by no means a Jenkins expert, but I'll be happy to answer anything I can. Well, I will say that my background with Jenkins started about 5 years ago, and we were just spinning up our Agile practice, and we were trying to get the Agile religion inside of Agilex, and I was brought onto a team that was supposed to serve as an example to the rest of the company, and we hired a coach from the outside, and he said, here's our best practices, continuous integration, version control, testing, and well, of course, the Agile stories and task boards. And that was my first in-depth visit with Jenkins, and the gentleman I was learning from was already very competent with it. He knew all the plugins, or many of the plugins, and even today I still find myself going back to the work he brought to us to figure out new approaches and how to use some of the existing tools. All right, well, then thank you all, and I think that's it for this session. Appreciate your time today.